Hey everybody, welcome back. Now, Snowflake has become one of the major players in the modern data stack. And in this hands-on video, we're going to do a complete overview of the Snowflake Snowsight Web user interface. We're going to go through Snowflake's own 9 training notebooks to cover everything from how to load, access, and wrangle your data to important cloud things that you need to care about, such as compute, all the way to what AI features that you can use inside Snowsight. Well, let's dive on in. The content I'll be going through today comes from a real recent enterprise Snowflake training that Snowflake held at the organization that I work at, which is one of Australia's large banks, where the Snowflake team took participants through 9 notebooks or labs. Now let's just quickly go through what we're going to be learning through these 9 labs. So the first one, lab number 1, this teaches you how to operate inside the Snowflake learning environment, and we'll dive into that shortly. Lab 2's on identity and access and something called context, which you very quickly learn to appreciate to prevent frustration. In Snowflake, I can't see something in my UI often turns out to mean my current role does not have the right privileges. Lab 3 builds a mental model of where Snowflake objects live and how your current database and schema context affects what you can do. Now in Lab 4, this is where Snowflake starts to feel like a real database. We're going to create tables. We're going to choose data types, insert rows into our tables, and get really hands-on. Lab 5 is about compute. A Snowflake warehouse is a compute engine. It's powerful, it's elastic, and it's cost sensitive. So you've got to be careful how you treat your compute engine. Lab 6 shows that Snowflake isn't just a database you manually insert rows into. There is built-in data loading features, and there's even a data sharing marketplace. In Lab 7, we look at how to verify various things in your Snowflake environment using code and metadata rather than just clicking around the UI. In Lab 8, we dive into some modern Snowflake patterns, things called stages and the copy into syntax. And we're also going to look at how to deal with semi-structured data. And finally, in Lab 9, we're going to wrap up by looking at how to use LLMs in Snowflake to process some unstructured data. I've got a feeling that this is going to be a long video. Yeah, well, we'll see. Now, before diving into the notebooks, let's just do a quick run across the user interface. So here, what we're looking at, this web interface, this is called Snowsight, right? This is Snowflake's Web UI. It's where data analysts, engineers, data scientists are going to interact with the Snowflake data platform. Now, it's also worthwhile doing a quick run through the main buttons on the left side navigator. So first up, projects. This is where your hands-on work lives. Notebooks, dashboards, Streamlit apps, workspaces. We're going to be spending most of our time here because this is where you actually do work inside notebooks. Now you'll see that I've actually got 2 windows open, one on the left and one on the right. Now this right one is pretty much going to spend its time permanently in projects because that's where our notebooks live and it's where we do our work. Next button on the left, ingestion. Now this is where data enters Snowflake, whether it's from files, cloud storage, stages, we'll learn about that later, or external systems. Next up, transformation. So this is where raw data gets cleaned and turned into useful analytics-ready tables. AI and ML. So this is where Snowflake's AI features live, including Cortex, LLM tools, search, agents, and machine learning. And we'll see throughout this video, we can actually access a lot of these features just via notebooks. Next up, monitoring. So very important one. This is where you check what you ran, how long it took, whether it succeeded or failed, what compute it used, important for things such as debugging. Apps. So this is where Snowflake hosted apps live, including apps your team builds or installs from the ecosystem. Next up, marketplace. So this is Snowflake's app store for data, connectors, and third-party tools that you can bring into your Snowflake account. Okay, so 7 buttons related to working with data. Now, if we go down below to Horizon Catalog, so this first button, Catalog, this is your map, I guess you can call it, of Snowflake, databases, schemas, tables, stages, data products. This is a really important place. It's where you can surf your data assets in a GUI format. In fact, you can see here in my left window, we're pretty much going to dedicate this left window to the Data Explorer under Catalog. It's going to be very valuable to have this alongside notebooks. All right, data sharing. So this is where Snowflake lets teams share data securely without emailing files, making messy copies. Governance and security, right? This is where access, roles, users, policies, data protection, it's where all that's managed. Okay, moving on to the managed set of buttons. We've got compute. So this is where you manage the engines that run your queries and spend your Snowflake credits. Postgres, we're not going to spend too much time in here, but this is where Snowflake offers managed Postgres for more application-style database workloads. Admin, this is where account level controls live, and it includes cost tracking, very important, unless you don't care about how much cloud compute money you spend. All right, well, let's dive into the first lab, the first notebook, how to interact with Snowflake using the Snowsight user interface. So we've already talked a bit about what Snowsight is. So let's scroll down. There is a concept known as a workspace. So if I expand this left pane, I can go into Workspaces, and this is the more modern user interface for Snowflake. In fact, what I had just shown you is actually known as legacy notebooks. This interface here is going to be deprecated fairly shortly. And what's the main difference between interacting with notebooks in this legacy environment compared to using Workspaces? Workspaces is basically closer to a Jupyter Lab environment. It's closer to a real IDE experience. You can organize files, you can bring up terminals. It's something more modern for the developer. But for this tutorial, I'm actually going to stay with legacy, partly because I actually think, so if I've got a separate tab here for the workspace environment, I feel like the notebooks look a little bit better under legacy. The cells are they stand out a little bit better. So for this video, we're actually going to stay on legacy. And also for this particular training that we all participated in, these notebooks were designed more for the legacy environment. So I can't guarantee that all the cells run if we run them under workspaces. Okay, so if we stick with legacy, we've looked at workspaces. This Python-based worksheets, that is something that you can only do in workspaces. So if I go to add new, right, I can make a new SQL script, a new Python file, .py, and this is what's known as a worksheet. All right, moving down, Snowflake Notebooks. So this is what I'm in right now. I've got a Snowflake notebook open up. It's very similar to a Jupyter notebook if you've used that before, with some extra bells and whistles. And of course, in the new workspace environment, you can certainly load up your notebooks there as well. But again, we're going to stick with the legacy environment just for UI purposes. Okay, scrolling down. So before we can do any sort of compute, run any cells, you do have to, because this is cloud computing, you have to spin up resources. So here, what I'm going to do is you need to click on this start button, and this spins up some compute for you to run your cells. All right, there we go, active. And if I click on the settings, so if I go to edit settings, we get some information about how compute works in Snowflake. So your SQL-based queries, they use what's known as a query warehouse. So just be a little bit careful. The term warehouse, it's not referring to a data warehouse, right? A place where data is stored. In Snowflake, warehouse, it means compute, right? So this is your compute engine for SQL, right? For SQL queries. And then there's runtime, which is essentially what's going to run your notebooks. And here you have two choices. Now this, let me just stress that these notebook settings, this is for the legacy environment. We'll check out what the compute interface looks like when we look at workspaces shortly. But under legacy, you have runtime for running notebooks. And here you have two choices. You can run on warehouse, where Snowflake essentially spins up a little bit of compute just to keep the notebook humming along. And then you can also run the notebooks in its own container environment. Right, and they have different use cases. So containerization, running your notebooks on a container, this is a bit better for AI and ML workloads, partly because you get to choose GPUs as well. But for more simple queries, for things that are heavy SQL, running on warehouse works well enough. Okay, and I just want to get you guys acquainted with some terminology that's going to crop up over and over and over again in this video. Turtle07, this is my login. Right, this is the login that was assigned to me from the Snowflake team during the training. So that's my logon, and WH, that's just warehouse. So, but this Turtle07, that's going to show up over and over and over again in the names of logons, in the name of databases, and so on. Okay, so long story short, a whole bunch of us in the training session, we had our logon was Turtle07. Turtle is an animal, and then they had different animals for that clustered different groups of users together. Right, so Turtle was just the one that I was assigned to. All right, let's get out of the compute settings. Okay, so we've started our notebook session. Now, if I scroll down a bit more, this is just teaching you how to execute cells, how to run cells, how to delete them, and so on. Over here, we have cell basics. So if you're kind of new to working with notebooks, how to work with cells. So for instance, we can add new cells of different types. There's Markdown, where you want to do some documentation, right? Hello, welcome to my video, Snowflake, yay. Right, so this is really just documentation. We can also spin up a SQL script. right, where we can put in a SQL query and run that. We can have Python cells, and then we can delete cells. So I'll delete the 2 that I just made. And we can rearrange cells as well by dragging this handle here, right? So fairly standard stuff if you've worked with notebooks before. All right, I'm just going to delete this cell too out of OCD. Okay, and now we're going to get into the running of cells. We've got an active session, so we're good to go. This is the first cell we're actually going to run. It's a SQL query, right? Which is going to output the date today, June the 20th, which means this account, right, which was provisioned for me as part of the Snowflake training. I took this training, I think, around May the 25th. So it's going to expire in a few days' time, which is why I really wanted to get this video out shortly, right, before this account expires. Thank you to Snowflake for funding the compute of this YouTube video. Okay, let's execute our first Python cell. Now, there's actually some important functionality that we should unpack. So this notebook is, well, at least this cell currently is, it's running Python code, but the data and tables, it lives inside Snowflake. So how does Python talk to Snowflake? That's where this Snowpark comes in. Right? Snowpark is Snowflake's Python API. It basically lets Python talk to Snowflake tables, run SQL, create data frames, and otherwise interact with objects inside Snowflake. Right, so this is loading up some important machinery to enable Python to interact with Snowflake. This line of code here, it's grabbing the current active Snowflake connection and it's storing it as a session object. And then off this session, we can do work in the notebook. In this case, some pretty simple work. It's going to create this, firstly, an empty, well, a data frame with one placeholder value in it. And then in there, it's going to inject the current date. So, and that's how we get June the 20th. Okay, moving along. So Jinja syntax, very cool. So Jinja is a templating system, popular templating syntax in Python. And what it allows you to do is to essentially strategically put placeholders in your code that you can then leverage later on. And what's interesting about the way it's implemented in Snowflake is you can actually integrate this templating inside SQL queries. So to walk through a simple example, right, we have a string, welcome to this course, and it's saved into a variable greeting. And then in Python, we can reuse this save variable, right, which is pretty standard stuff. But what's cool is that with Jinja syntax in Snowflake, we can actually pull up this variable and inject it into a SQL query, which is pretty cool. So you may have some Python scripts which produce certain outcomes that you save as a variable, and then you can reuse, you can pull these variables into your SQL workflow later on in your notebook. Okay, finally, test your knowledge. We've arrived at the end of lab 1. At the end of every lab, at the end of every notebook, the Snowflake team has put in these test your knowledge multiple choice quizzes. Some of these are actually pretty good for reinforcing your knowledge. Let me hide this code. Actually, let's look through this code. So this is a Python script. It uses Streamlit, which is a handy way to build web apps using Python. And Streamlit here is actually being used to generate these multiple choice questions, which is pretty cool. So for user experience reasons, let me hide this code because I don't think I'm actually meant to show this code. I think this is how we're supposed to consume this cell. So we can't see the code, but we run the cell and it essentially generates the multiple choice questions. Okay, which statement is true for Snowflake interfaces? So they each have object browsers. So I think this refers to the information at the top of this notebook, which is that Snowflake user interfaces, it is an object-based UI navigator. So object here refers to things like databases, schemas, tables, and so on. Okay, and I think there's one more multiple choice question. So let's run this one. So I'll show you the code for this. So code and results, right? Okay, I'll hide that. I'll run it. So the question is, what is true for Snowflake interfaces? JavaScript, Scala, COBOL, we haven't heard of anything about these languages, but SQL and Python, right? These are your two main bread and butter languages used to access, play, and wrangle with data inside Snowsight. So that wraps up lab 1. This really was a bit of an orientation lab. Right? The main point is we're not going to build a complex data pipeline just yet, but we do need to get comfortable with the Snowflake interface. Right? So we looked at how Snowsight is organized, how notebooks are structured, how SQL cells, Python cells, Markdown cells, they all live together in this same workflow. One useful thing to note is that Snowflake notebooks, they're not just passive documents, right? They are interactive working environments where you can run SQL, you run Python, you document your thinking in one place. That's the purpose of notebooks. So before getting to databases, tables, warehouses, AI functions later on, Right? Lab 1 gave us the basic controls, right? Where things are, how to run cells, how to interact with Snowflake from inside a browser. I just remembered, almost forgot, that we need to talk a little bit about compute for running the notebook under a workspace. So just to recall, right, if we want to edit our compute settings for notebooks under legacy, right, we use a query warehouse for SQL-based workflows. And for running the notebook and running Python, we need to select a runtime, right? So here we have the option of using a warehouse-based compute and also running in a container. Now in a workspace, what options do we have? So if we run the notebook cells in a workspace, let's create this compute resource, and it's what's known as a compute pool. So let's just wait for this to finish provisioning. Okay, we can see it's connecting. Okay, it's done. Comparing the compute between workspace notebooks and legacy notebooks, this compute pool essentially maps to running the notebook and Python under a container, and SQL queries still run under a query warehouse. Because if we go to here, we can see the query warehouse that's being used. So in a nutshell, this connected button, this is strictly talking about Python and running the notebook. And for SQL-based queries, we are using a query warehouse. Anyway, we'll talk more about compute in Lab 5. Okay, so let me jump into Lab 2. Now, before I can do that, when you're running a legacy notebook, you basically have to shut off the compute engine, your query warehouses, before leaving the notebook. So let me end this session. And then I can get out of notebook number 1 and go into notebook number 2. All right, so this lab is all about, well, identity and access. So we're moving on to Snowflake security. And in a nutshell, this lab teaches us how roles, privileges, access controls, all of that determines what you can see and do inside Snowflake. Okay, so the first thing I'll do is, of course, start a session. So I have some compute to run through my cells, and then I'm actually just going to run everything. At least I'll attempt to run all the cells. We'll find out that some of these cells are not going to run. It's going to be an error, but that's okay. All right, so this opening cell is very important. Often in all of these notebooks, we have a cell like this that we run towards the beginning, and it spins up some important machinery, your current context information. So context is this very important idea in Snowflake because it tells you information like what account are you using? So what account am I using? This is the name of the account, right? I logged in using this account. What is my role? Turtle07, so that's the animal assigned to me when I did this training. And then there's learner RL. So roles are very important because, as we discover, if you don't have the right role equipped, you can't do certain things, right? And because you might forget what role you're under, because it's not entirely visible to you in this GUI interface, you might forget what role you currently have equipped. And then when you try to access certain databases or do certain things with tables, you might run into permission issues, right? So knowing what the context of your current session is, what the state is, so what role have you currently equipped, it's very important. Also, context is what database is currently being assumed that you're working under by Snowflake. So this is also important because say you're trying to access a certain schema or use a certain table, but you don't have the right database equipped, you're going to run into privilege issues as well, or database not found sort of issues. So context, very important. And I discovered this the hard way when doing this training myself. Okay, so let's move on. So we're going to create a new database shortly. But before we do this, Snowflake kindly reminds me that my animal, right, which forms, it's essentially a prefix for everything that I create in this training, whether it's a database, schema, table, right, it's going to have this turtle07 prefix in front. Okay, and then I'm going to make this database. It's going to be called turtle07 underscore database. Now, how do I make this database? I'm going to equip a role. So this is going to be the turtle07 learner role. And this is going to be the role that I spend the majority of my time in. This is the role where I'm supposed to be doing most of the stuff as part of this tutorial, making the databases, making schemas, making tables, sending off queries, doing analyses, playing with AI. It's mostly meant to happen in this learner role here. Why am I turtle07? So I'm going to repeat this because otherwise this double brackets with user inside is going to confuse people. Turtle07, that's who I am. If I go back to the top, your current user is turtle 07. And then if I write this quick query, select current user, this verifies that it's total 07. Okay, so my role is currently total 07 learner role. If I didn't have this role equipped, so what other roles are there? There are 5 roles here. This is where I'm going to spend the majority of my time. I'm going to spend a little bit of my time in this role as well, total 07 create database role, but most of the time I'm going to be in here. If I were in one of these other roles, what this use syntax does is it equips this learner role if I wasn't already under the role. Okay, and then under this role, I'm going to be creating databases, schemas, tables, and these created objects, databases, schemas, tables, are going to be owned by this role. And importantly, they're going to be visible only under that role unless I grant privileges to access those objects to another role. So very important to understand. And again, that means that if you forget which role has been equipped, this is where you might find issues like can't find database, can't find table, and so forth. So this is going to be my role, total 07 learner role. I'm going to create a database, and it's going to tell me it already exists because I've already created it. Where is it? It is this database, total 07 DB. If this didn't exist, then this query would succeed. Well, this query would run and tell me that the database, a new database would be created. So moving on, we've created a database, and there's a cell here that teaches you how to do it without using code, using a GUI interface. So here, this is where we go to our Database Explorer. Now, I've got this open, and I'm going to have this Database Explorer open for the entire duration of this tutorial because it's so useful to be able to see visually all the databases, schemas, and tables that I'm going to be using. But to get access to it, to reach it, I expand the left pane to show all these main buttons, and it is under Catalog. Right, I click on Database Explorer under Catalog. I'm going to be able to create a new database with this plus database button. So if I go into that, I could name it total 07 DB, and then chances are it's going to tell me that it's already created and therefore I can't create it. Yeah, so compilation error, it already exists because we use code to generate it. But if we had not ran this code and this database didn't exist, if you want to, you can use the Database Explorer and a GUI interface to create the database object yourself. Moving on, this SQL script is going to list all the databases that has in its name somewhere total 07 DB, and well, there's only one database that fits the bill, which is total 07 DB. And also note who the owner is. So it is owned by the role that was used to create it, and that's the total 07 learner role. Okay, now let's explore the impact of changing roles and what that does to visibility. So if I go down here and click this button at the bottom left, I can switch my role from the role that I'm going to be spending most of my time in, which is the learner role, to a role called create database role. As soon as I've switched, you can see straight away that I have a different set of databases that I can see that's available to me. And in particular, the new database that I just created, total 07 DB, has disappeared from here, right? Why has it disappeared? Because it was created by that role, it's owned by that role, and by default, only that role can see that database. So if I want to see total 07 DB here, I need to get that previous role to grant me a permission to be able to see the new database under this different role. Okay, so now let me switch back to learner role. And here we are, total 07 DB has reappeared. I can see it again. Moving on, we've got some cells on exploring the new database. So, so first up, use role, total 07 learner role. So this is just to be safe, just in case I forgot to switch back to the learner role and I was still stuck in the create database role. This code here makes sure I'm in the right role where I can see the database I just created. So let's run this cell. So describe is a piece of syntax that focuses on one particular item. So in this case, I'm going to focus on a particular database, which is the Total 07 database, and it's going to describe everything about it. In this case, what's the next level down? It's going to be 3 schemas, right? Cloned objects, information schema, public. You only should be seeing information schema and public because these 2 schemas are created by default when you make a database in Snowflake. The reason why there's an extra thing, an extra schema, cloned objects, is because that's actually something I made from a later notebook. So pretend it doesn't exist just yet. In any case, describe database Total 07 DB. It's listing all of the schemas for that database. And here, this cell repeats what I just mentioned about the information schema and public schemas being the 2 schemas that are created whenever you make a new database. There's also the show syntax, the show command. Now, one thing you might be wondering about is what's the difference between show and describe? So describe focuses on one thing, right? So in this case, you're describing a particular database and it's going to give you information about it. In this case, the bunch of schemas that fall under it. Show is by default meant to produce a list of things, right? So you're showing schemas, right? All the schemas, right? Multiple schemas, producing a list of all the schemas in a particular database. So describe focuses on one thing. Show, you're producing a list of things. All right, so this code lists all the schemas in the Total 07 DB database. These are the names of the schemas, as we can see here in our database explorer. Which database do these schemas belong to? They all belong to the Total 07 database. Who are the owners? That's the role that created it, right? The learner role. Notice that information schema doesn't have an owner, and that's because it's something that's managed by the Snowflake system. It's always created whenever you spin up a new database. Okay, moving on. So we have some information here on using the database explorer to navigate databases, schemas, and so on using a GUI interface. Let's do that now. So if we go to Total 07, we're at the database level. If I go to the schema tab, I can see the 3 schemas. Now, what if I go down to this schema level? So if I go into public, all right, I've got some information. Note this button here, privilege. Right, we're going to go into that later on. This is how you grant the ability for other roles to see objects that you've created under this role. Okay, now we navigate to the information schema. We can see lots of views. So no tables, but lots of views. And these views provide information about underlying data, right? So this is all about metadata. Going back to our notebook, how does changing your role affect what databases you see? So we've talked about this already. If you change to another role, generally speaking, you're going to see a different set of databases. So if we use code now to switch to the create database role, so that will be the same as going down here and switching the role to the create database role. If we use code and equip that role, and then show our databases, list all the databases that we can see under this role, we see a bunch of different databases compared to when we're using the learner role. Okay, and now we're using code to switch back to the learner role. So switching back from create database role to learner role, and then listing the databases, we see our original list of databases, including the one we created, Total 07 DB. Okay, fantastic. Challenge exercise. Okay, so this is where sometimes you have to fill in some blanks, otherwise the queries don't run. If we look at this navigator on the right, which allows you to quickly navigate to the different cells in this notebook, the color coding is pretty cool, right? So green means that the cell has executed. Now, what about the blanks? It's blank, there's no color because these are markdown cells. Okay, but the green ones are cells that require execution. So it's basically it's either going to be a SQL script or it's going to be a Python script. See this blue dot? So that's a cell that has been modified, but not yet executed. If I go to a cell that I haven't modified, cell 19, which is currently green, and then I press enter, now it's turned into a blue dot because I've changed it, but I haven't saved and executed it yet. But if I execute it, it should turn green. Fantastic. So now let's go back to the cell that I was running, the challenge exercise cell. We tried to run the cell and it ran into errors. Why? Because there is a missing keyword here. Under our standard learner role, we want to create a new database called util.db, right? Basically meaning utilities. This keyword should be create. And now if I run the cell, it's going to work. It tells me it already exists because I previously ran this cell. And then if I go back to my database explorer, I can see that it was already there. Okay, by this stage of the training, there should be 3 databases that I've created. Turtle07DB, which is right here. Turtle07 Resources DB, which is here. Yeah, I can't remember if I created this. Maybe this was already here, provisioned as part of the training. And Turtle07 Util DB, I just created. It's important to do these checkpoints because these notebooks they layer on top of each other, right? So if you don't create the right things, you don't have privileges set up correctly, you don't have the right objects ready, some of the cells in the future notebooks may not run. Okay, what am I doing here? So I'm doing another stock take of databases. This time I'm in my usual learner role and I want to show all the databases under this role with Turtle07 in the name somewhere, and I can see 4 databases. Oh, this one here, Turtle07 Garden Plans. So we haven't created this yet as part of either lab 1 or 2. This is something that I created as part of a later lab. And this database is actually going to play a huge role across this tutorial because a lot of the dummy data sets we end up using is going to be plants and garden themed. And by lab 9, we're going to be using AI to generate insights on various plants. So it's going to be interesting. Okay, challenge exercise. Granting usage. So how do we, if we create a database under a certain role, how do we grant the ability of another role to see the database we've created? Turtle07DB. How do I grant this role to be able to see that database? So what I can do is I can go into this database, press plus privilege, and then let me search for the create database role. What privilege am I going to grant this role? The usage role. Okay, and then I'm going to grant that privilege. And now what this means is that this role can see this database. So let's check that. If I now log into the Turtle07 create database role, I can now see, right, the Turtle07 DB is now visible. It's available in my list of databases under the Database Explorer, which is pretty cool. So this also asks me to grant, to make a certain schema available as well. So if I go back to the learner role, the notebook has asked me to grant this schema visibility for that role as well. So Turtle07, create DB, privileges, usage, grant privilege. And now if I log back into the create DB role, I can see the public schema under Turtle07 DB. Now I may have already been able to see, so this is a bit of a nuance. When this role is granted the ability to see this database, it may be able to see these folders straight away, but it doesn't mean that it can see everything under the database, right? So there is a level of separation between granting access to a database versus the underlying schemas. If you want a certain role to be able to see everything under a schema, you actually want to grant that role access to the schema you're interested as well. Okay, scrolling down, I think we are hitting the end of this lab. Test your knowledge. So this is the multiple choice quiz. Based on your work in the following is true about database ownership. So this is the one, ownership of a database initially resides with the role that created it. Okay, if you have a certain role equipped, you make a database, you're by default the owner. If you know a database exists but suddenly cannot see it, or you get an error message that says doesn't exist, what should you check first? So you're gonna make sure this, we've talked enough about this. Context. You've got to check what your current role is to make sure that you're in the role that has access to the database. So select current role. This is a pretty nifty query that's useful to just whip out when you need to. If suddenly you have some sort of access issue, running this query just to quickly check which role you're under, or you can always do it here as well. Check which role you're under, right? Very helpful for troubleshooting purposes because it might tell you straight away, oh, I'm in the wrong role. That's why I can't see a certain database or a certain schema. Okay, that wraps it up for lab 2, identity and access. All right, we are on to lab 3, database object hierarchy. That's the name of the lab. And look, it builds a mental model of where Snowflake objects, databases, schemas, tables, where they live, and how your current database and schema context affect your ability to pull off commands. So it really reinforces some of the concepts that we've talked about already in lab number 2. Okay, so let's go through the cells. First up is our basic machinery cell, right? Making sure that we have a session attached to this notebook and also printing out important context information, which account I'm using, what role is currently equipped, what database is equipped, which schema is being assumed, and again, reminding us that our username is turtle07. Okay, Snowsight object browsers. So this is reminding us the usefulness of being able to browse the database explorer, look through which databases we have under a certain role. Now let's see if they want us to check out anything in particular. Open database details in a new tab. So that button doesn't actually seem to be available to me. Don't know if that feature's been deprecated, but if I just click in to the database, like really when you expand this button here, it's just taking me into this screen, giving me information about the schemas and other information that might be useful. Okay, lab exercise step by step. We actually have to hit some benchmarks on certain things that need to be done to set us up for some future labs. So in particular, we need to make a new database called garden plants. It needs to have certain schemas created, and it needs to have a schema dropped. Now, I have already done this when I was playing with this earlier. We can see under the database explorer, turtle07 garden plants, this database has been created. I've got these 3 schemas they're asking for, flowers, fruits, and veggies. They've already been created, and we can see that there is no public schema. It's been dropped, right? It's created automatically when you make this database, but now it's gone because I've dropped it previously. Okay, we talked about this in the last notebook. Cell status color. Okay, blue means that it's been modified, but it hasn't ran yet. If I go back, this cell has successfully ran, but if I do any modifications, the green has turned into a blue dot, meaning it's modified, but not yet ran. And then I don't have any red cells, any cells which fail to ran, but so maybe I'll run everything and just to see if I run into any red cells, any cells that fail to execute. Moving green, the cell is currently running, so it's very cool. We can actually see which cell, where we're up to in the notebook in terms of what's being ran. Very cool. Okay, so it looks like all the cells have finished running and they were successful. Okay, show commands. We talked a bit about this in the last lab as well. So show naturally produces a list of things. So in this case, we're going to be listing all the databases under the turtle07 learner role. And we're using code to generate this, but we can also just check it out in the database explorer. So this list here of databases is exactly the same as this list of databases here. Okay, show schemas. This is going to list all the schemas for a certain database of choice. For the turtle07 garden plants database, what are the schemas? We looked at that earlier. There are 4 of them: flowers, fruits, the metadata schema, information schema, and veggies. Here they are listed. Change the database schema and run the same command. Okay, so now if we change the database, right, if we change the context of our database from one to another, if we switch to this database and then show schemas again, it's going to list the schemas for that database. So let's use code to equip the Snowflake sample database. If we then run the command to show the schemas there, it's going to show a different set of schemas. So these schemas here are actually part of some benchmark datasets that are often provided as part of sample datasets that people can play around with. So TPCH, so this is a benchmark dataset. It's designed around a simplified business commerce scenario. Essentially, it's a fake wholesaler order management business. You've got customers, orders, line items, and so on. Basically, some play datasets for you to muck around and experiment with. Okay, so if we run show tables, we can see what tables are available under a particular schema. Okay, so we've got a bunch of, well, pretty much dimension tables, customers, line items, nations, orders, right? Various entities as part of this play sample data set. So here we're going to get some practice querying from these sample data sets. So this one basically outputs the nations available in the sample data set. This is going to get accounts of how many rows are in the largest table, and the largest table is line item, and it's got just over 6 million rows. Next query relates to orders, which time period, does the orders table cover? So the earliest order date, 1992, Jan the 1st, and then that goes all the way up to 1998, August the 2nd. So roughly a 6-year period. Okay, next query. So we're going to select all the rows from the supplier table, which satisfies a certain condition. The account balance is more than $9,995. Cool. And then we have an aggregation here. So we're grouping by the market segment to get a count of the customers in each market segment. So we've got 5 segments, and these are the counts, the customer counts. So touching base with where we are, under the learner role, we've created a new database, Total 07 garden plants. There are 3 new schemas we've created, veggies, fruits, and flowers. And we're going to populate some data in some of these schemas in the next few labs. And also we dropped a schema. The public schema should be gone. Okay, test your knowledge. So we're at the end of this lab. Let's see what the quiz questions are this time. Okay, so this one is on the color of the cells. Which of these is true? We know that red is when an error has occurred. There you go. That's the correct one. Next question, you've created a schema called veggies. Yes, indeed we have. We run show schemas in a SQL cell, but it doesn't appear. Okay, so you've created a schema. It doesn't appear. So this is some sort of a privilege problem, a context problem. Maybe you're not in the right role, but assuming your current role has access to the schema. In other words, you've double checked somehow, either by looking at verifying that your role is correct visually down here, or you've select current role to check that your role is what you expect it to be. So assuming your current role has access to the schema, you still can't see that schema. So what's the problem? So the answer should be, you want to make sure that you're in the right database context, not just the right role context. All right, so to use a real example, you're in the right role, right? So you're in the learner role where we're pretty much doing everything in this tutorial. And let's say you're trying to access the veggie schema, but you can't. You're in the right role. What's the problem? Chances are you're not in the right database, right? Your database context is wrong. You might be in another database, such as Total 07 DB. So what you want to do is switch your database context to the garden plants database, and then you'll be able to access the veggies schema. So here, if you type in current database, it'll tell you which database context you've currently equipped for your session. And right now, if I was trying to access the veggies schema, yeah, I would run into issues because instead of having equipped the garden plants database, I've actually equipped it. I'm still right now sitting inside the Snowflake sample data database, which I used earlier to pull in those public benchmark datasets. So if I go use database, Turtle 07, garden plants, run that, it'll put me back into the right database, and I can check with a quick check of my current database that I'm in the right database context. And then if I show schemas, and it's going to list me the schemas that I can access now in that context, that database context, and veggies is in there. Okay, cool. Well, that wraps up the lab, and we touched upon some pretty important ideas. We ran a number of SQL queries to show off what the interface looks like. We reinforced ideas behind objects in Snowflake and also how context affects what you can and can't do inside Snowflake. All right, let's hop into the next lab. All right, lab 4, almost halfway. So this is where we're going to start creating our own structured data, right? The lab's going to teach us how to define tables, choose data types, insert rows, and perform some basic table operations inside Snowflake. All right, so let's dive on in. So first up, I've got an active session. Let's run all the cells, see what we get up to before something fails. I'll also check out my context information. So we've got our account, we've got our standard learner role loaded. We've got the garden plants database. That's our current database context. Our current schema context is veggies. And again, friendly reminder, our username is Turtle07, which basically prefixes the majority of objects that we create in this tutorial. Okay, so we're going to be looking at a dummy data set that's going to help us make some objects. So let's just acquaint ourselves with what data we're looking at. We have something called the root depth of a plant. And really we've got 3 data points, 3 classifications to work with: shallow, medium, and deep, based on how deep the root actually goes. So essentially we're going to be creating 3 rows into a new table, root depth. So let's get on with that. We equip our learner role, which we're already in, but just in case we were in any other role, this equips the right role. And then we're going to create an empty table, right, under the garden plants database. Under the veggies schema, we're going to create this table, root depth. It's going to have 6 fields, and these are the corresponding data types. So if I run this cell, now because I have already created this table earlier, it's going to tell me there's no need to create the table. It already exists. In fact, if we go to the database explorer, here's the database, here's the schema, veggies, here's that table, root depth. While we're here, let's do some navigation. There is an AI generated description of the table using Cortex, which is Snowflake's native AI. Here's the table definition, right? This is the exact query we just saw that was used to create the table. Privileges, so currently I haven't granted any other roles to be able to see this database. I can go to the columns tab to see the 6 fields that are present in the table. I can even check out a preview of the data. Now, technically, there should be no data in here because we haven't created any data. We haven't loaded any data into the table. But the reason why there is data in here is because, again, I've already done this tutorial, right? So I've already made some data and I've inserted it into this table. So what I will do is I'm going to drop this data. Oh, actually, this is going to drop the table from the system. So if I drop the table, it's certainly going to drop the data. And then what I should do is run this query again to create the table from scratch. There we go. This time it didn't say that it was already created. It created it because it didn't exist. Okay, so now if I refresh my database explorer, go into tables, under veggies, I can see root depth, but this time around it should be a blank table. If I go into data preview, there's nothing there. Okay, fantastic. Okay, so we've just done some exploration inside the database explorer. This is some guidance on what to do if you screwed up the query to create the table. So for instance, if you named the table wrong, so instead of naming it root underscore depth, if you named it, hypothetically, if you named it root depth, right, all in one word, you can use this alter table syntax to rename the table into the correct name. Another example, if the table name is correct, so root underscore depth, you got that correct, but you accidentally created that table in the wrong schema. So instead of creating it under veggies, you created it under flowers. So the table would then appear under flowers instead. That's also going to create problems later on. So you can also use the alter table syntax to rename the schema from flowers to veggies, right, which effectively moves the table over under the veggies schema. Okay. View the definition of your table under Database Explorer. We did that just earlier. And now we're going to insert some data into our empty root depth table. Now, this part is important because essentially what it's doing is summarizing for us 3 different ways of loading data into tables. We're not going to see all of them in this lab. In this lab, we're going to focus on using insert within SQL queries to load data into tables. But throughout the later labs, we're also going to see how to use something called the load data wizard, which is a GUI way to drag and drop files and sideload them into Snowflake, and also a code-based method, copy into syntax, to also load data into Snowflake. So by the end of this video, you're going to know 3 ways of how to load data into Snowflake. All right, so now we're finally going to insert some data into the empty table. We're going to use the insert command, right? This is going to, by running a query, a SQL query, a DML, data manipulation language query, we are going to insert a row, 1 row into the table. So here we're going to put in a row for the shallow root depth. So if I run that, number of rows inserted, 1, fantastic. If I now refresh and check out the data preview, I can see now there's 1 row in our table, our root depth table, fantastic. Here's some guidance on if you get some sort of permission error, and this is, again, troubleshooting through context. Are we in the right schema? Are we in the right database context? Are you in the right role? If you get any sort of errors like that. All right, and now we're going to run a simple query to just check up on the state of the data. So we can see the data visually under Database Explorer. There's 1 row, but we can also use SQL to check out what the table looks like. So select star from root depth. So this is only going to work if my context is correct, right? I'm in the right table, in the right schema, in the right database, using the right role. Fantastic. I can see the row that we created earlier. Now, just to validate the context is all good, select current role, current database, current schema, current warehouse. Okay, I'm in the right role where I want to be. I'm in the garden plants database context. I'm in the right schema context, query warehouse we're using. Fantastic. Everything's going well. Here's some extra syntax that you can use to help you calibrate the precision of your queries. So if we use the exclude syntax, it removes certain columns that you don't want to see. So in this case, range min and range max. So out of the 6 fields in the table, we're going to exclude these 2 from showing up. Next one, by the way, you can see some of these previous outputs. These are outputs that I generated earlier when I ran this notebook and I was playing around. Okay, if I run this cell, what this is going to do is it's going to grab the values in this field, right? Root depth code, and it's going to concatenate on this suffix. So S for shallow got this extra bit added at the end. Another SQL query. This one renames certain fields. So range min became root depth range min. Range max, there we go, got renamed into root depth range max. So a bit more descriptive. Okay, in this one, it's going to select all of the fields that have root in there somewhere. Another common SQL syntax that you may have seen. So this is fairly introductory SQL material, but worth covering, is limit. So Snowflake uses ANSI SQL, or it's very close to ANSI SQL or standard SQL. Limit is actually apparently not ANSI SQL. From memory, it started off as database specific, used in MySQL, PostgreSQL, and also SQLite, but Snowflake also supports it. So this query here is going to select the 1 row from the root depth table. And just as well, there is only 1 row currently in the table. So this would output the entire table. But if you had a million rows, it would output the first row. Okay, challenge exercise. We've inserted this first row, right, representing shallow root depth into the table. And now this challenge exercise is asking us to insert the next 2 rows, the final 2 rows, medium root depth and deep root depth. What makes it a challenge is the fact that they've left some of these things here blanks for us to fill in. Okay, so we're going to insert the medium root depth. What information do we need? The code, which is M, the root depth name, which is medium, the unit of measure, which is always centimeters, cm. So let's run that cell. Number of rows inserted. Let's refresh our database explorer. Hopefully we see 2 rows now. There we go. The new row appearing right there. And now let's also inject and insert in the deep. Whoops, pardon me. I naturally just gravitated towards L for large. Deep, so D for deep root depth. And then unit of measure is still centimeters. Let's run that. And that's going to insert in our 3rd and final row. And then if I refresh the database explorer, we can see, fantastic, our completed root depth table, shallow, medium, deep. Okay, and now we've visually inspected the completed table. Let's now run a query to check that everything looks right. Yep, that looks great. Here's some extra guidance for those new to SQL. And I think we've almost hit the end of this lab. So let's check out the quizzes. Okay, Snowflake made minor changes to the SQL as it created the table. What changes were made? Oh, that's interesting. I didn't even notice that. So if we look at the original data set, so if we look at when we created the table, the data types were number, text, 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 number, number. But if we go into the table details, in particular the table definitions, the data types for the strings were changed to variable characters. Okay, interesting. So the correct answer is Snowflake converted the text data type to varchar. Next one, how can you preview data in a table while in a notebook? You can right click on a table name and on the table name and choose the table preview now option. You can find the table in the object. I think this is the right one. In the object picker, click on the table name and then click on the magnifying glass symbol. I don't think we did this. Let's just check that out. Oh yeah, this, I think we can't do this. Maybe the feature's been deprecated or is currently unavailable, because if I go to here, we tried this earlier, there's nothing that shows up. But that's okay, because when we press this button, it just loads this page in a separate tab. Okay, was that the last quiz question? No, there are more. Okay, where are we? What is the role of a limit syntax in a select statement? So this is where you want to restrict the number of rows that's being returned. So that will be this one. Which role should own your root depth table created earlier? So this should be, the schema should be veggies, and the database should be garden plants. And the role should be the role that we're using to create all our databases, which is the learner role, right? So that should be D. Okay, and that wraps up this lab. Okay, lab 5 is on warehouses, and we're going to be very careful here. When we say warehouse, we're not talking about data warehouses, we're talking about cloud compute. This lab is all about how to understand compute engines, how to get information on the compute resources you're using and you have used in the past, also how to manage your costs. Very important, especially if you work in an enterprise where you've got some sort of cost center funding your cloud compute, or whether you're doing this personally, which means you're forking out the bill out of your own pockets. Okay, so let's go through the cells in this lab. So first up is our opening cell, which is almost always the same, loading up the right notebook session and just double checking on context. And then we have some information about some basic concepts with cloud compute. So at a very basic level, one of the benefits of cloud computing is what's called its elasticity. So as you need more resources, the cloud compute can either scale out, which basically means provision more virtual computers or resources in the cloud to meet that demand in workload. It can also scale up or down, which basically means for each computer that you're using from the cloud, you can make that computer more powerful or less powerful as needed. And here, again, it's reminding you that if you're new to Snowflake, that this term warehouse, don't get that confused with data warehousing. If you see the term warehouse in Snowflake, it's referring to a virtual warehouse. It's a concept around compute, right? Warehouse means Snowflake compute. And I'll just mention that when it comes to scaling, so personally, I work in a bank. The ability to scale up is quite important when we're dealing with big data and users are throwing complex SQL queries, right? So when you have complex joins, transformations, that's when you want to be able to scale up, right? Make the machines that are processing those queries as powerful as they can be, right? So more virtual cores, more memory when it comes to dealing with concurrency issues. So in a bank, often you have many employees in head office trying to do data analytics at the same time during the workday, and you might hit what are known as concurrency issues, too many users hitting views, hitting tables. So that's where you want the ability to scale out, right? Provision more virtual machines as needed to meet the demand in concurrency. Okay, moving on. So this is some guidance on being very careful on what sized compute you use. Don't just choose the largest compute that you can. You want to use one that is commensurate with the workload that you have, because when you use large warehouses, when you throw a lot of compute onto a workload that doesn't really need that compute, you're going to be forking out a lot of money unnecessarily. Okay, so now we're going to dive into some compute information. So what I'm going to do is go into compute. I'm going to click on warehouses, but I'm going to load this into its own separate tab. So here I can see a bunch of different warehouses that's relevant to me. I've got two that's on. There is a warehouse that's used to process SQL. And then there is a warehouse that is being used to essentially process Python and to keep my notebook alive. And I can also check that out here. If I go into edit settings, I've got my query warehouse where I'm processing SQL queries. That's this one here. And then I've got my runtime for Python and for keeping my notebook alive. And I'm currently running on what's called warehouse. You can either choose to run your notebook in Python using a container or on warehouse compute. We're currently running on warehouse compute because we're not really doing anything that needs containers, not doing any sort of ML or AI work. So we're using warehouse runtime, and that's also reflected here. That's this one, that's this row here. Now, what does the notebook ask us to do? It wants us to modify the compute. So it wants us to switch from extra small, which we're currently on, to small, which means instead of costing 1 credit per hour, it's going to cost us 2 credits per hour, which of course has cost implications, right? So you really should be doing this only if you need it. We are being funded. We are being bankrolled by Snowflake, thanks to this being a training environment. So thank you very much, Snowflake. So I'm going to go to, which compute am I changing? It is for Turtle 07 warehouse. Okay, so if I go to edit, I'm going to switch from extra small to small. I've got some options here as well. Auto resume, where basically if I do anything, it's going to automatically spin up the query warehouse just in case it was paused. There's auto suspend, which pauses the compute if I haven't been active for a certain amount of time, in this case 10 minutes. Multi-cluster, this is the option you would want to have enabled in an enterprise setting where you have potentially concurrency issues, right? Lots of users hitting views and hitting tables at the same time, and you need to be able to cater for that extra concurrency. Query acceleration, so this is where my understanding of this is if sometimes you submit a query on a small number of occasions, there might be some edge cases that demands a lot more compute than usual. If you enable query acceleration, then the query warehouse is going to throw some extra compute for those rare situations where you can really make use of some extra compute. Okay, so I've switched from extra small to small. Let's save. And now that's it. I've just, with a click of a button, thanks to cloud technology, I've now suddenly got a more powerful computer to run my queries. Okay, so there we go. We've used code to check up on the current configurations of our warehouses. We've got a query warehouse and it is now small when it was previously extra small. It did say medium here, but that's because I've done this lab previously and I was playing around, and the last compute size that I had set things to was medium. So the current query warehouse size is small, which is what we want because that's what we just changed over here. We went from extra small to small. And if you don't want to press buttons, you can use code to also set the warehouse size of your choice. So this is how I got medium earlier on, right? Because this code made it medium. So if I run this code, if I run this SQL script, execute it successfully. So now if I rerun this previous cell, it's going to reflect that I've now upgraded my query warehouse size to medium, from small to medium. And if I also refresh the warehouses page and explore visually, I can verify, indeed, the size is now medium. Okay, fantastic. Next part of the notebook is costs. How much all of this compute is costing me? How can I monitor it? What you want to do is go into this page, cost management. So let's dive into that now. It's a very interesting page. So in the left pane under admin, go to cost management. I'll also load this into its own page, into its own tab, just because I might want to keep this tab open for the rest of this lab. Fantastic. I've got some visualizations that tell me straight away how much compute this account is using. Now, I don't think I have access to all of these tabs. So organization overview, no access anomalies. I don't think I have access either. Budgets, don't have access. Resource monitors, don't have access. What I can see is account overview and consumption. So account overview, on average, I'm using 18.7 credits per day. So each credit is going to cost a certain amount of money. Now, the interesting question is this, who's using this, like credits used by whom? Is it just by me? Or is it by a bunch of people, right? So that's an interesting question. I can also dive into the amount of credit spent broken down by the query warehouse, right? So the common query warehouse, which actually is a shared warehouse, that's racked up the most amount of credit use. Total 7, that's me. But at the same time, it's actually not just me, because a bunch of people, participants at the training, also shared the Turtle 07 warehouse. So it's not just me, it includes a few other people. If I go into the query tab, it tells me which query spent the most amount of credits. This is a query that falls under the common DB database. So chances are, workshop configurator. So this was actually a Streamlit app that provisioned all the notebooks for every person at the training. So you can imagine this probably as an aggregate cost a lot of compute because you had to run an app, which is probably a bunch of Python scripts in the back to generate all these notebooks and provision the resources. So yes, not surprising that this process generated a lot of credit use. We can also look at spend by database, tags. Yeah, no spend data available. If I go to consumption, so this is interesting. So it breaks down compute credits used to Friday, June the 18th, a lot of usage, probably because I'm guessing maybe people knew that their training environments were about to expire. So they did a lot of work on Friday, and that included me. I'm guilty. What's nice about this data is it breaks down by day, and also for each day, it breaks it down by the query warehouse as well. So we can see this big red rectangle. That's the common warehouse. That's the shared one. That's provisioning all the resources. And then the green one, that's system, Streamlit notebook. So that's something else that's kind of system-based, right? Not really compute that's used to do data analytics or anything like that from users. This is more of a infrastructure. If we go back to 28 days, the last 28 days, so this is very interesting. Now, all of a sudden, the compute use that we just saw over the last week pales in comparison to this huge spike here with a lot of use. And so this was the day that we did the training. You can see all these different profiles here, right? Where's our one? Turtle, where's Turtle? Can't even see it here. Oh, I can scroll down. Okay, so wow, there's a lot of different animals here. But this was the day that the training was held. And this was the day that obviously the majority of compute occurred because people were all sitting on a call together over 4 hours playing with these notebooks. But then we can see that participants continue to use their accounts over the next month, playing with these notebooks and doing these tutorials. So yeah, very interesting data. If I go back now, some of these cells probably asked me to showcase what I just showed you. Lesson 5 challenge exercise. What is the average daily credits for the last 28 days in this account? So I think we looked at that in the account overview. We spent 18.7 credits per day. Now again, this is the average daily credits for a bunch of people. It's not just myself. This is probably at the account level. So it's probably, I'm imagining it's at this level. That's what it's referring to. The figure is 18.7 credits per day. And I contributed to that, but I'm not responsible solely for burning up this many credits per day. Thank goodness. Well, I guess it wouldn't matter because Snowflake's paying for it. But yeah, I wouldn't want to be paying for this. Using up 373 credits myself. From memory, I think a Snowflake credit. Actually, let's check it out. How much does each Snowflake credit cost? And just because I'm based in Australia, I'll put it in AUD. Okay, so it varies based on which region, the data center, but between roughly $3 to $5 per credit. So I'm looking at between $900 to $1,500 roughly for if I was solely responsible for burning up all of these credits. Yeah, wouldn't be cheap. But that's how much it costs Snowflake to run this environment for these people. What is the largest database? If I go top spend by category, that was the Snowflake database. Is that what we're looking for? What exactly is this database? Let's have a look. Okay, so I'm in the standard normal learner role. This is the database, Snowflake. Okay, so it looks like some sort of system managed database. We probably don't have to concern ourselves too much, but this was spending, from a spend perspective, this database was spending a lot more than the others. Which users is responsible for the most expensive query during this period? Okay, so if we go to the top spend by category, the query tab, it's this query that we looked at earlier, this query that's used to help spin up resources for everyone who participated in the trainings. On which day were most credits consumed during the last 28 days? So we looked at that just then. It is the day that the training occurred, which was on May the 25th, where everybody logged on and followed the trainers as we went through these 9 labs over 4 hours or so. And then finally, has AI services consumed any credits during this period? AI services. Is this what we're looking for? Yeah, okay, 11.5 credits used. Don't really have much data to visually see, but it's telling me 11.5 credits. Well, Lab 9 contains AI content, right? You're using Snowflake's AI infrastructure to do some of the stuff in Lab 9. So it would make sense that the number of credits used by AI services is a positive non-zero number. Okay, fantastic. Moving on. Again, some guidance on if things are not working, check your context. Are you in the right database, right role, right schema? And I think that pretty much wraps up this lab, which is true about Snowflake warehouses. So warehouse is compute, so it's not referring to a data mart. Functionally, a Snowflake warehouse is more like a spreadsheet. Again, this is not right because a warehouse is not data, it's compute. Snowflake warehouses provide computing power to run queries, load data, and carry out other tasks. Yes, I'd say that's correct. Okay, next one. Scaling out and scaling up and down are easily confused. So which is true about scaling Snowflake warehouses? So if we change from extra small to a medium, is that an example of scaling up? Yeah, that's the right one. Because scaling up is when you make the individual computing resources more powerful to handle more complex queries, more complex transformations. So that's pretty much what it is. Let's just quickly go through the others to understand why they're not correct. So if we go from an extra small to an M, that's not scaling out. Scaling out is when you provision more computers to do jobs, but not making any of them, you're not making them more powerful, you're just making them more numerous, right? You're provisioning more nodes or virtual machines. When extra small warehouse automatically adds clusters. So this is, again, scaling out because you're adding more computing resources, like you're adding more computers to the job as opposed to making the computers more powerful. So this third option is actually an example of scaling out, not scaling up or down. Yeah, similarly here, this is wrong for the same reason. When you add clusters, you're scaling out, scaling in or out, you're not really scaling up or down. On horizontal scaling, so what's the opposite of scaling out? Well, that's going to be scaling in, well, in this case, actually scaling back. Descaling, that might sound right, but descaling kind of implies you could either be vertically scaling or horizontally scaling back, reducing your compute horizontally or vertically. Shedding clusters, I mean, I could imagine this being correct because you have horizontal scaling and you want to cut some of that out. So you want to shed some of those clusters that are no longer needed. So I could imagine this being right, but it turns out it's not the right answer. Scaling down is definitely wrong because that's vertical scaling, where you're grabbing individual nodes or VMs and you're making them less powerful. Next one, warehouse scaling involves both servers and clusters. Which statement about servers and clusters roles in warehouse sizing and scaling is true? A server is basically a node or a VM, virtual machine, and a cluster is a set of these VMs or nodes, right? So in theory, it should be D. A cluster can hold multiple servers. When should you scale up an existing warehouse? When you're bored and it seems like something fun to try. Yeah, if you're rich. When you have carefully considered the impact of scaling up. Yeah, that sounds about right because it's going to cost you more money. All right, lab 6. So we're going to be looking at two things in this lab. Number one, the load wizard, which is another way to load data into tables. This time around, instead of using insert SQL queries, we're going to be using a GUI interface to essentially sideload data into tables. Very cool. And Snowflake Marketplace, this is an external marketplace inside the Snowflake UI where you can share data assets or data products and also download or buy data products that you're interested to use. All right, so let's dive into the notebook. I've got my session active. Let me try to run all my cells, see if anything gets stuck anywhere. Let's go through everything. All right, as usual, we have our context information. This notebook, this lab, and also future ones, we're going to lean more heavily into this plants and vegetable theme. These data sets here, they're not just illustrative data sets. I think it's a good idea to acquaint yourself with the content of these data sets, which is different types of vegetables. It's actually going to come in handy in the final lab where we make use of these data sets as part of some AI-driven analysis. Okay, so apparently there are some issues with these flat files. The obvious one, if you stare at this for a minute, is this entry down the bottom, because if this is meant to be a CSV that's delimited by a comma separated values, peppers, hot is really meant to be one vegetable, but this comma here is not meant to be delimiter, but it's going to be treated as such. So there are going to be two delimiters, which is going to break reading this CSV. Let's get started with setting up some foundations. We're going to create a table that contains information, details about vegetables. So this is a blank table. Create table. If it doesn't exist, where are we going to put this? So this is the fully qualified name. Turtle07 garden plants. That's the database. What's the schema? It's going to be the veggies schema. And the table name is vegetable underscore details. It's going to have two fields. The name of the plant, right? Plant underscore name, which is going to have a certain data type, 25 characters long, and also a root depth code. Right now, what were the root depth from earlier labs? It was, well, we had 3, right? Either short, medium, or deep, I believe. So the code would probably be S, M, and D, and that's why it's only 1 character long. This is interesting, data retention time in days. So this is to do with keeping a backup. We'll talk about that later on. Anyway, let's run this cell to create this table. And that's because, like we've seen already many times, because I've created it previously. If I go into garden plants database, veggies schema, surf the tables, I can see vegetable details has already been created. Now we are going to populate this empty table with some data. Now, because I've done this previously, chances are the data is already in there. Yeah, it's already in there. So that's not good. That's not good. So let's drop this table actually, because I want to start from a clean slate. So now I will recreate the table, successfully created, and that gives me an opportunity to load this data in fresh and demonstrate what we're trying to demonstrate, part of this tutorial. So this piece of code here, what it does is it grabs some data from using what's called a stage. We're going to talk about stage in lab 8, but basically it draws data, it pulls data from an external storage area. Actually, it could be internal or external, but it pulls the data from somewhere and then it creates a downloadable link for us to download the data. So this is meant to simulate that we have the data externally somewhere. We have the data somewhere else that's not in Snowflake. So what I'll do is I'm going to grab this data and it's going to be saved into my hard drive, and I'm going to pretend that it was data that was on my hard drive and I want to get that into Snowflake. So now what I'm going to do is go to the data load wizard, what is it? It's basically a GUI way to sideload data into a table. So which table am I sideloading into? Vegetable details. So if I click into vegetable details, I can see this load data button. That's the wizard. I click on the button. I'm going to drag the file that was just saved into my download folder into the drop-in pane here. Okay, I'll press next. And then it's going to bring up the wizard, right? That's why it's called the data load wizard. It's going to give me a bunch of options. Now, this is an interesting one. If I go to view options, I've got a bunch of options. Firstly, I can see that just looking at this data preview, artichoke, right? That's the data. That's data. Plant name is not data. That's really a heading, right? So is routing depth. That's a heading. It's not data. So the header, there is certainly header in the data file. If I look at the data itself, if I use Excel, this is what the data looks like. Make it bigger so we can see. Okay, artichoke all the way to kale. Remember, this is half the data set. So this one goes from A to K. I can see the names of the plants and I can see the rooting depth. But the problem with using Excel is that I don't get to see certain information such as what the delimiter is. So a better idea is to actually load the file in a text editor. So I'm on a Mac. So I'm going to use text edit to open the file. Okay, so I can see that the delimiter is definitely a comma. So it's a delimited file and comma is the right choice. As for header, let's choose first line contains header. And oh, this is an issue because if we go to the empty table that we created, the names of the fields, these are the names of the fields. But if we look at the data set that we're trying to import into this table, the names are actually different, right? Plant name is not the same as plant underscore name, and routing depth is not the same as root underscore depth underscore code. So there is a mismatch in the fields in the raw data set and the fields that are actually in this table that's meant to be a destination for this data set. So what I can do is just a quick mapping. Plant name, the name of the field in the file, should map to plant underscore name in the table, the empty table, and routing depth in the raw file should map to root underscore depth underscore code. And that'll fix the column name mismatch issue that we're experiencing. Another approach you can take is just click on skip first line, and you'll see that this automatically fixes the problem. Why does it fix the problem? Because it just matches things up positionally, right? So in the file, what it's saying is the first column is automatically going to match up to the first column in the table, which is going to be plant underscore name. And the second column in the file, which is routing depth, is automatically going to match up to the second column of the table, which is root underscore depth underscore code. And that achieves the same outcome. Okay, either way, we've resolved that problem and I think everything else looks fine. Yep, and double quotes is what we want. Field optionally enclosed by double quotes. So this is important because that means for these values, everything that's enclosed between the double quotes is the value of the field. If we have this turned off, right, basically none or single quotes, not double quotes selected, what's going to happen is it's going to treat this comma as a delimiter, in which case this row here is going to look like it has 3 columns, which is then going to break the import. So we want double quotes enabled. Okay, fantastic. Let's click load. And now the data has been successfully loaded. And we can check that if I refresh the Database Explorer and then go into Data Preview, I can see the data we've loaded just then. Fantastic. Okay, truncate. Okay, interesting and very useful syntax. Well, if you mess up the loading of the data and you need to basically empty the table, I should have used truncate earlier because there's been a couple of times where I had a table and I wanted to empty the table of contents. And instead, I just went here and dropped the entire table when I could just drop the data within the table, which is a slightly less scorched earth policy. Now let's download the second file. So the second file is we just side loaded the vegetables between A and K. And now we have to do the rest of the vegetables from L, I guess, all the way to Z. So if you run this code, it's going to generate a file you can download. So if I click on that, It's going to download the veggies from K to Z, and then I'm going to load that into the vegetable details table. So let's go and load the data. So I'm in the vegetable details table, and what I really want to do is I want to append the rest of the vegetables, right? From the rest of K all the way to Z. So I'll do exactly what I did earlier. I'll go to the data load wizard, and this time around, I'm going to upload the second file from K to Z, press next. And I've been warned that the columns are not separated by commas this time. If I open the second file with Excel, basically if I open it as a spreadsheet, right? Indeed, I can even just tell from the spreadsheet alone that the delimiter seems to be a vertical bar, vertical line. I can probably make that a bit more obvious if I open it in text edit. Yeah, so this is the second file, and we can clearly see the delimiter is no longer a comma, it's a vertical line. Okay, so gotta be careful. If I go to view options, once again, we have a header, and I don't want to run into the same column name mismatch issues earlier. I'm just going to be lazy and click skip first line, and that's going to match things up positionally. That looks good. Snowflake was smart enough to identify that the delimiter was a vertical bar. Okay, let's load that data in. And then if I refresh, hopefully I've got all my vegetables inside this vegetable details table. Cool, we're done. I've got 42 vegetables loaded into this table, and each of them has its root encoded using its root depth code, short, medium, or deep. Okay, so we've visually inspected the completed vegetables details table. The notebook is asking us to validate that with code. In other words, run a SQL query and print out the table. Turtle 07, garden plants, and we want to use the schema. So right now I'm setting context, use schema, veggies, select everything from vegetable details. And there we are. Here's the table with the 42 entries. It only says 41 because the first row starts at 0. Okay, so it turns out this table has some data quality issues, because if we look at spinach, there are 2 entries for spinach. One entry says that its root depth is short, and another one says that its root depth is deep. So this is a data quality issue, and we have to resolve that. So this query here is going to get us to print out the 2 instances of spinach with different root depths. Vegetable, details. This is interesting. You just want to get every instance of spinach that pops up in the table. You don't care how it's spelled. You don't care what case some of the letters are. It doesn't matter how you spell spinach. And one way to make this happen is to level the playing field and just make everything uppercase. Spinach. And when I run this query, it's going to find me all instances of spinach being used across the data set, irrespective of case. That verifies we've got just these 2 entries that essentially should just be 1 entry. The notebook is going to lead us to do this programmatically, right, using code, as opposed to using some sort of GUI way to delete one of these rows here. So we're going to run a query to programmatically isolate this row, spinach, and we want to isolate the deep version of spinach. And now that we've isolated that, we've selected that row, this one here, and now we want to delete it. So it's going to be the same query, but instead of select, it's going to be a DML, data manipulation language. We're going to delete that row instead. Okay, I'm going to run that, and we've deleted 1 row, which is going to be this row here. If I refresh the page, let's just check that that row is now gone. Yep, only the short root spinach remains. The deep rooted spinach has been purged from the table. Okay, fantastic. And now programmatically, we're going to verify that by running a SQL query and print out the table. So select star from vegetable details. And this time we should have 1 less row than before. Yeah, so 41 entries now instead of 40, because the deep rooted spinach has been deleted. Okay, fantastic. Moving on to actually a related topic, which is cloning datasets. Now it's related because cloning allows you to essentially make a copy of a dataset, which you can think of as loading data, right? You just happen to be loading the same data, but you are still loading data by cloning an existing dataset. So why would you clone a dataset, and what does that mean, and what are the use cases? So let's run this query, and what it does is in this database, now you can see cloned objects already, this schema, right? Because I've ran this previously. What you're going to do is you're going to create this clone object schema. Inside this clone object schema, you're going to create this table, vegetable details underscore clone, which is just a copy of the vegetable details table, right? That's all this SQL query does. It's going to tell me that it already exists. No worries. And the way this works is it's called a zero copy clone, because when you clone this table, it's not the same as duplicating the table, right? If you duplicate the table, it's a new table. I'm sure it's the same as the original one, but physically you've copied the data as well. When you clone a table, it's called zero copy because it's actually still pointing to the same underlying data set as the original table, which means that from a physical storage perspective, this clone data set, at least for now, it doesn't take up any extra footprint. This next query is going to print out the original table and its clone. So that's these two here. This is the original vegetable details table, and this is the clone we just made. Notice that one of them, the original table, lives inside one database, the garden plants database, and the clone lives in a totally different database. This cloned table doesn't actually take up any extra physical storage, at least for now. Okay, let's query the clone. We verify it's got the exact same data. Now, when it comes to storage implications, if you make a change to either the original table or the clone, right? So either this table or this table, that's when you're going to be adding new physical data as well. But while you don't make any changes to the clone, it's not going to take up any extra footprint because it's going to point to the exact same data that sits under the vegetable details table, the original table. Now, the use cases for cloning data is firstly backup, right? It's like when you're working in data science, sometimes you've got a data frame DF in your notebook and you want to do some modifications to it, but you don't actually want to override the original data frame, right? You want to preserve that data frame. So maybe you might do a df.copy to make a copy of that data frame and then just play with the copy, right? So this is a situation here where you've got some sort of underlying table and you want to preserve it. So you clone that table and then you can work on that clone instead. That's one use case. Another use case is you can actually clone entire databases, right? Not just tables. So this is a way to, if you have a whole database and you want to have different environments for that database. For example, a dev database, a test database, a sit database, production database. You can easily grab a database, its current state, and then just duplicate it for a different environment purpose. And yeah, otherwise, backup, experimentation, these are all valid use cases for wanting to clone a table or a database. Okay, moving on to a slightly different topic now, but still related because this lab is all about loading data, and this topic here is related to loading data, but in a way it's not. We're talking about a marketplace for data. You can get data into your Snowflake instance, but you're not actually loading it at all. You're just downloading what's already in the marketplace, or you're buying it, you're exchanging data products in an online marketplace. And this ties into, if you work in enterprise data, you might have heard of the data mesh architecture, where different, for instance, divisions of an organization or nodes of a data mesh, they produce their own data products, which are quality, reliable, reusable data assets, which you can then push to other nodes in your organization. In other words, push across the mesh and therefore share your data assets, your data products. So this marketplace works in kind of a similar way. Different people will publish their own data products, and then you have this marketplace which facilitates the sharing of these data products, right? So here's the marketplace. Let me search for books. And the first thing that shows up is AI training dataset from Goodreads book. So this is datasets generated by Goodreads. It's also free. If I click in, I can find out information about this dataset, a data dictionary giving me the field names, the data types. I can press get, although I don't know if this training environment is going to give me permission. Yeah, so my role, unfortunately, I don't have the privilege required to get this data set. That's okay. Okay, moving on to data sharing. So that's accessible through this button, data sharing. There's both internal sharing and external sharing, right? So internal sharing, that's for people within your organization, right? So if you're making data assets, particularly sensitive data assets that might have commercial value that you don't want to share outside of your organization, you just want to share data with your colleagues and teams internally, this is the place to do it. And then there's external sharing. And immediately we can see a bunch of what looks like to be public data sets that has been shared with me. If I click on more, I can see this data set, Alpine Peaks Publishing, which has already been installed for me, which is good because the notebook wants me to play with this data set using some SQL queries. This call command here associates this data set with my role, my Turtle 07 learner role, so I can actually access the data set and query it. Okay, so now that connection has been made, I can run some queries. How many reviews are in this data set? 88. Let's see if I can validate that. If I go to catalog, Alpine Peaks Publishing, if I go to books, that's the schema. And then if I browse the tables, the table name is forthcoming releases for books. I preview the data. Yep, so these are the books, 88 books, corresponding authors, corresponding category that the books belong in, and also when the release date was or is meant to be. Okay, 88 books. Let's run some further queries. So this is just printing the first 10 books, limit 10. This query just outputs the categories of books available: astronomy, children's, cooking, finance, gardening, history, memoirs, woodwork. We've got 8 categories. Now let's look at the number of books within each of these categories, right? So woodwork and astronomy and finance, they have the most number of books out of our list of 88 books. And since we're apparently so obsessed with gardens and vegetables, let's find books with garden in their name. So these 3 books have garden in their title. And then this query is going to list all of the books where the category has garden in it. Now there's only one category that has the word garden in it, and that's the gardening category, right? And we've got 10 books in the gardening category. Let's just go back up and double check that. 11. Oh, right, because the index starts at 0. So we do have 11 books in the gardening category. And I think that pretty much wraps up the lesson. We have the quiz. Okay, just one question in the quiz. What is a file format? So a file format, for instance, a CSV, it's a way to tell Snowflake how the data is going to be structured, right? So it should be A. Cool, well, that's that lab. All right, lab 7 focuses on how to check your code has ran properly and it's doing what you want it to do. And this is important because it actually sets up some checkpoints for a lot of the stuff that we've done in the past 6 or so labs, making sure that we've set up our databases, schemas, tables correctly in preparation for the final 2 labs where we're going to make use of some of these assets, these data assets, these tables that we created to do some analytics. Okay, so let's dive on in. I've just ran all of the cells and it looks like they've all successfully ran. Fantastic. But as usual, our first cell is to set up some context and make sure that our session, our notebook session, has kicked off, no dramas. Okay, so this first cell is we're going to query some metadata from the information schema of the garden plants database. So if I go into garden plants, we've got this information schema, which is always created whenever you make a database, and it contains a lot of metadata on your database. So inside the schema, there is a view called Schemata. If I preview the data, I can see 4 schemas in the garden plants database. Now you might be wondering, well, like we can see it in this database explorer. Flowers, fruits, information schema, and veggies. The thing is, because that information is in a view, means you can query it. GUI is nice for looking at things, but there's a limit to how you can actually use that data in a programmatic sense. In other words, using code, we can actually find out using this schemata view what the schemas are in a database. And that's going to allow us to do certain checks. For example, this check here. Check whether or not we've completed some of the instructions in the previous lab correctly, which is that we've created 3 schemas, flowers, fruits, veggies, and we dropped the schema public, right? The public schema that we were asked to drop a number of labs ago, if you remember. So this query does this check. What it does is it goes through this view and it counts the number of schemas that we were meant to create. 3 of them, flowers, fruits, veggies. So that's going to output the number 3. And then there's this check, whether the number of schemas that we were meant to drop is 1, because we were meant to drop the public schema. And then finally, it does this reconciliation. If the number of schemas we were meant to add is 3, and the number of schemas that we were meant to drop, and therefore shouldn't exist anymore, if we count the number of schemas called public in the garden plants database, it should be 0. If that's true, then it passes this check. Okay, this query just quickly checks whether the names of my schemas are correct. There are no typos. And now we're going to launch into a bunch of checks the Snowflake team has set up. Now, I don't quite have the logic how these checks were set up. They are in this common database, which is system managed. So if I go into common database, resources, and local grader. So this is a procedure. It's a stored procedure. Right. If I go into this local grader procedure, I've got a procedure definition, but I don't think this is complete because it doesn't really tell me what exactly is happening under the hood. But that's okay. I'm just going to assume there's some logic in the background under the boot that is going to do some rigorous checks for me. And here, what's it going to check? It's going to check that I've created flowers, veggies, and fruits. Yes, I passed that. Fantastic. The next check, it's going to check whether I've deleted the public schema from the garden plants database. Yes. Next up, have we created the root depth table in the veggie schema in the garden plant database? So if I go into garden plant, I go into veggies, I go into tables, I can see the vegetable details. Whoops, pardon me, wrong one. Root depth table. So this should pass the test. Fantastic, I passed. Wonderful, lovely. Small pivot, if you want to kind of do a bit of an audit to check whether your queries have executed properly, right? You want to check out the details of the queries that have executed. You can go to, so if I go to a query, right, it tells me how long it took to run, but I can also click on it to view details of that query run. All right, so this tells me when I ran the query, how long it took, what query warehouse settings I used. So here I used the medium warehouse to run this query. And I can get even more detail by clicking on this link here, which is going to take me to the query history page. And that's going to give me a lot more information about this particular query hitting Snowflake. And I can see the results. I can see what this query actually was. And you don't have to find a query and go through this pathway to get into query history. You can click into monitoring and it'll take you straight into the query history page, which lists all of the queries that you've ran. And if I want to find the one that I just investigated, 8E9A, 8E9A. So that was this one here. Right, so this was the same page I was at earlier. So if you want, you can go into monitoring, querying history, and you've got the list, the full list of queries that you've ran. Okay, moving on. We see the line here saying, do not proceed past this point unless you see a green tick in all of the checks beforehand, right? Because we're going to be using some of these things that we've set up later on. And if things didn't run properly, it might present some problems. Okay, access query history programmatically. So if I don't want to serve query history, right? If I don't want to look at things using monitoring and I want to output information about my runs by running code, we can do this as well. So here is a query, which is going to use this function, query history by user, to output query runs. So in particular, this output one query, namely one where it was a delete exercise that was successful. Well, I've only ran a delete query once, which was to delete that duplicate spinach entry. So this query here has brought up the backend query ID, which deleted that spinach entry. Moving along, this query is very similar to the one we just ran, but all we're doing is grabbing the query ID and we're saving it into a variable that we can later reuse. Okay, next check. We're looking at the database Turtle07 util.db. So that is going to be this database here. And we want to see, just to check that it's got two schemas. So it actually has three schemas because we created cloned objects. Okay, so the next check is on Turtle07 util.db. We want to check whether or not it contains just two schemas. So let's go in and yep, it's got the information schema and it's got public. So that should pass the check. Next check, have we successfully created the vegetable details table? If we go into garden plants, veggies, tables, and there we go, we've got the vegetable details table. So that should pass the test. Okay, check number 6, does the root depth table contain 3 rows? So let's check by inspecting it in the data preview tab. And yep, we've got our 3 rows there. So that should pass the test. Okay, next one. Does your vegetable details table contain 41 rows? So we had 42 rows, but we had 2 entries, both spinach, that were considered duplicates, right? A data quality issue. And we deleted one of the spinach entries. And let's just double check that visually. So vegetable details, data preview, 41. Okay, 41. Looks good. So that should pass the test. Okay, moving on to time travel. So this is kind of like version control, where Snowflake saves previous versions of a table, and you can use that to revert changes within a certain window of time. So here it says, when we loaded the vegetable details table with data, it was configured at the time with 7 days worth of data retention. That means that we can navigate back in time to view the data associated with the table at any particular point in time within those 7 days. Okay, so if we run this query here, so this is an interesting query, right? It's got two parts, right? This part and this part. Now this part here, this first half of the query, what it does is it uses this special Snowflake syntax that starts with the before command. And what it does is it basically grabs the previous snapshots of the vegetable details table. That's going to output the duplicate spinach entries and tells us here that these are historical snapshots. Separately, the second half of this query grabs the current version of the vegetable details table, which only has one spinach entry, and it's the current version of the table. And then this union basically brings together, combines all of these results. So we see all of these different versions of the spinach entries. We've got the historical versions and we've got the current version. So that's time travel. Very interesting. Okay, and I think that brings us to the end of this lab. Let's check out the quizzes. What is the definition of metadata? So this is a pretty straightforward one. Metadata, right, is data about the data. Where does Snowflake store some of its metadata? So the information schema of each database, that's where the information schema is a dedicated place to store metadata for a database. So that's the right answer there. If we want to check the schemas, for the schemas we created, why not just look with our own eyes to see if they're there? So again, being able to visually inspect things is pretty nice. It's intuitive, it's visual, it feels real, but there are limitations to what you can do with that information. So firstly, if we misspelled something, you might miss it visually, but if you try and detect for those changes programmatically, you'd find it, assuming your code is correct. I would argue that B is also correct, because if you just look for things visually, you can't really automate things, but by checking for errors programmatically, that enables you to set up automations that check for problems. So I'd say both A and B are correct, but hey, there can only be one right answer, and Snowflake has picked A to be the most correct answer. Okay, that's lab number 7. All right, lab number 8. Who's still with us? It's a very long video, isn't it? So this lab here is a data engineering themed lab, and it teaches us how Snowflake stages work and how we can use the copy into syntax to get data into Snowflake, and also how do we handle semi-structured data formats such as JSON using what's known as the variant data type. Okay, let's dive in. First, I'll run all the cells and see where the notebook breaks. All right, so as usual, we have our context information. And now let's talk about stages. One way to think about stages is that it creates a connection between Snowflake and data that might live elsewhere. So for this notebook, we're going to be creating a connection between Snowflake and the underlying data which lives on Amazon S3. So let's set up this connection, this stage, so that we can bring in this data from Amazon S3. Now the database we're going to be creating a stage in is going to be the Turtle07 util DB database. So let's go to that, Turtle07 util DB, and we're looking at the public schema. Now you can see that I've already got a stage created here because of the last time I did this tutorial. So let's delete this stage, drop stage. Okay, so I've got the public schema open, and we're going to create an external stage to Amazon S3. So I'm going to go to create stage, external stage. This external stage is very similar to the idea of an external data source if you're familiar with Microsoft Azure Cloud and also Google Cloud. What configurations are we going to make for this external stage? So we should call it like a window into an S3 bucket. Like a window, not going to lie, my working memory is shocking right now because it's very late at night. Into an S3 bucket. Okay, and by the way, this name is quite descriptive of what a stage actually does. It provides a window into this data source that's external to Snowflake. Okay, we also need a URL. Comment is optional. Authentication, that matters more for private S3 buckets. So here we're signaling that we don't really need to do any sort of extra authentication on top of what's already inherent as part of this process. Direction table. So this lets Snowflake keep metadata about the files in the stage, and that's going to make it easier to list and inspect the files. So I'm going to keep this option on. Auto refresh. So this is data refresh related. Encryption, I might keep that off. Yeah, I don't think I need to have that on, given that this is really just a training environment. Okay, so let's create this external stage. And there we are. Interesting, note that the name of the stage has been converted to all uppercase, even though I typed it in lowercase. So moving on, we've created an external stage. And by using this stage, I can browse all of these files that are sitting on Amazon S3, which I'm going to eventually bring into Snowflake. Okay, some information on the architecture of what a stage is and what it does. Moving along, so we can use the list command to view the files in the stage that we can see visually here. So let's try that. Great, we've got the names of the files, the size, the MD5 checksum, when they were last modified. Okay, cool. All right, this is interesting. Object naming conventions. Snowflake always assumes you really mean to type everything in uppercase, so it converts for you. So that makes the life a little bit easier because it prevents sort of mismatch issues due to object names kind of not matching because there's a mix of upper and lowercase letters. So an example of that is this stage here. We use lowercase letters, but it's automatically saved into Snowflake as uppercase. But this sort of conversion isn't automatic for Amazon S3. With Amazon S3, if you're going to be pointing or referring files sitting in S3, you've actually got to get the case right for all of these characters. Author with header.json with all small letters, that is a different file to author with header.json where like this was capitalized as capital A. Right, so just be aware of that. Okay, there's a quick check here on whether we've successfully created the stage. Yep, fantastic. Okay, copy into. So this is the third and final way that we're going to learn in this tutorial on how to load data into Snowflake. So just to recap, in an earlier lab, we learned how to use insert statements to inject rows into a table within SQL queries. We looked at the data load wizard, which is a GUI interface that you can use to drag and drop files and sideload them into Snowflake. Copy into is a programmatic way to load data into a table, and this time we're not just inserting rows. You can use copy into, you can use this syntax to copy a large amount of data by, for instance, pointing to stages that connect to upstream cloud storage, potentially semi-structured and unstructured files. Okay, so to set up the copy of data into Snowflake, we're going to first make an empty table so that we can copy data into it. We're going to make the table vegetable details soil type. It's going to have two fields, plant name and soil type. Now, I've probably created this table already. We might just be remaking it, but that's okay. Let's just check that it's there. So it's in the garden plants database. It's in the veggies schema. We'll go to tables and there it is, vegetable details, soil type. That's the one. Is there any data inside? There's no data, at least not yet. Okay, so now we're going to bring that data sitting in S3 into this empty table, right? Using the copy into statement. Now, what do you need for the copy into syntax? You need a table, you need a stage, you need files, and you need the format of the files, maybe. So to illustrate, let's check out this query here and I'll just run it. And yep, so the status is loaded. We have loaded a particular file sitting in S3. Let's check out which one it was. Veg name to soil type pipe.txt. So this file here, we've loaded this into the empty table we've just created. Now, where are these four things? In this query, we need the table to copy the data into. So that's this table, vegetable details, soil type. We need a stage, which makes a connection between Snowflake and S3, or as the tutorial framed it, the stage provides a window into the S3 bucket. So that was this stage that we created here, like a window into an S3 bucket. We need the file that we want to be copying into the table. So that's this file here. And then finally, we may need a file format. And in this case, we declare that it's a CSV with a certain delimiter type. It's a vertical bar, and we skip the header. So yeah, we've loaded the data into this text file, 42 rows into our vegetable details soil type table. All right, and then this is going to be a quick check to make sure that we've done that correctly. Great, we've passed the grading, fantastic. All right, and here is actually this is pretty instructive, some tips and tricks on data loading. So first and foremost, in Snowflake, the term CSV is used more broadly. It doesn't just refer to flat files with comma separated values. It actually covers all flat files, TSVs, text files, and so on. For the purposes of declaring what a file type is, even if it's one of these types of files, if it's a flat file, you declare it as a CSV. Second tip, the field delimiter property is very important. Right, so I think this one is pretty obvious. If you're going to be loading a flat file with a certain delimiter, you've got to make sure you declare the right delimiter, otherwise you're not going to be loading in the right data, right? At least in the format that you want to. And thirdly, the data load wizard can help you write your file format. Okay, so let's hold on to that one. This is actually a very interesting one, and it'll be easier to explain with an example coming up shortly. Okay, challenge exercise. Create a soil type lookup table. So yeah, we're going to create a new table, and we need to load some data into the table. And this time around, we can choose, well, we can load it however we want. We can use the copy into statement. We can use the GUI method, the load data wizard, but we find there's actually some synergy between these two approaches. Okay, so first up, let's create the empty table, loo soil type. So let's just check that we've created this properly. Garden plants, veggies, loo soil type. Is there any data within? No. Okay, now we're going to run this code, which is going to give us a link to download the file. So this is a situation where we pretend that we had this file, this TSV, tab separated value file. It was elsewhere away from Snowflake. Perhaps it was on our local machine, and we want to sideload the file into Snowflake. Okay, so what does this look like? Let me open the file with text edit. Whoops, that's not this one. This is the file. So this is the data. We want to sideload into Snowflake. Notice that there are no commas, right? The fields are separated with tabs. Okay, cool. Okay, so let's load this file into the table. Now here's where we go back to this tip here. Because suppose you wanted to use the copy into method, right? The programmatic method. You want to write code that loads the data in this TSV into the table. Then you're going to have to specify certain information, like what is the type of the file? What is the delimiter? Do we skip the header? Is the field enclosed by quotation marks? What have you? And this is where the GUI method, the data load wizard, can actually help out. And this might blow your mind. So if we go to the table and we click on the data load wizard, and I drag the loo soil type TSV into it, and then I go to next to get all the options in the wizard. Notice down the bottom here, there's this show SQL button. If I click on it, what do we see? Copy into. So it turns out that the data load wizard is actually just a GUI wrapper for the copy into syntax. Ultimately, whether you're using the data load wizard or just straight up copy into, in the end, you're always using the copy into method. But if you use this GUI approach, the load data wizard, and then go to see the SQL query, you can actually get the information you need for the copy into command. So if we go back, what information do we need here? Type, it's CSV. And that makes sense because earlier we mentioned that if it's any sort of flat file, we denote that as CSV. Field delimiter, it's a tab. And in hexadecimal, this is what it is. And then skip header, yes. And now we can pull the data in using the copy into command with the help of the data loading wizard to find out what some of the settings should be for the copy into command. Okay, here we go. We've loaded 8 rows, and then let's just check that the data looks okay. Refresh. And there we go. The data's in. Fantastic. Okay, let's run this check. Yep, it looks good. Okay, next section, working with semi-structured data. So semi-structured, I think the prototypical examples are JSON and XML. Now in Snowflake, the data type to support semi-structured data, it's called variant. So let's check out what that looks like. So here we're going to create an empty table called vegetable details plant height. And it's going to have one field called record, and it's going to have this data type variant, which takes care of semi-structured data types. Okay, so where is this table? Let's just check that it's been created. Vegetable details plant height. There it is. Okay, and now we're going to load some data into this empty table. So let's run this query, which is going to generate some data for us to download, a JSON file. Okay, so I've downloaded the JSON file. Let's take a look at what it looks like. I'm going to open the JSON file up in text edit. Okay, so this is what it looks like. It's got information about a bunch of different plants. It's got this nested JSON structure to give information about each plant. What's its unit of measurement, whether it's feet or inches, and then it's got information about the low and high range of how big these plants grow. Okay, so now we're going to use a copy into statement to load that JSON data into the table we've just created. So let's run this query. Okay, so it's pulled that data into the table. Let's check out what it looks like. I'm going to refresh the Database Explorer and then go into Data Preview. And there we go. We've got a single column record and it's pulled in information about those plants. Okay, cool. Let's try to query some of that data. So the first row, here it is. That's this row here. Okay. And now this is some general advice and guidance on how to query semi-structured data. You can use a colon to navigate to the element you're interested in within the nested JSON structure. So for instance, here we can see level 1 element, level 2, level 3. If we go back to our file, plant name, this is the level 1 element, level 2 element, level 3 element, level 4 element. If we want access to these different elements, this advice here tells you how to do it. So you can use a colon to access the nested structure of a JSON file. Wherever an element is in the hierarchy, you can use this syntax here to access what you're looking for. So let's look at this query here, which is a good example on accessing certain elements in the JSON structure and then pulling them into a table structure. So what this query basically does is in JSON, we have these key value pairs. Right, that's how the data structure. And what we're doing is grabbing these values. So first and foremost, the plant names, and then putting them into a column. And then we're grabbing the unit of measurement, grabbing these values, and then putting them into another column. And then we're pulling these values, the high end of range values, like how big these plants get, and putting them in a column. Although really it should be the third column, not the fourth column. Just looking at the order in which the data is arranged here. And then finally, these values, the low end of range for the plants, they're going to form their own column, which is here. So that's what this query does. It's basically grabbed the data inside the JSON and pulled them into a table format. Note that there's been no casting done on the unit of measurement field, which basically means there's been no casting. For everything else, so for all of these, plant name, high end of range, low end of range, these here have actually been casted, right? The data type has actually been converted into a SQL data type using the double colon syntax, right? Which is the same thing as casting, the cast function. Just know that the double colon syntax is not standard SQL, I guess you can call it. It's something that Snowflake supports, and I believe Postgres supports it. Yeah, but in any case, the unit of measurement was not casted into any SQL data type. And what that means is if we check out the table that's being created, the unit of measurement field, and this data type here is actually still a variant, and also it's a JSON string, right? It hasn't been converted to a SQL string, but it's still a JSON string, which has certain implications for downstream processing. So let's fix that up as asked in this challenge exercise here. We want to convert this unit of measurement field from a JSON string into just a regular string. So let's put that in. And then in our data set, the high end of the range occurred before the low end of the range. That's just the way the fields were ordered. So let's swap these two fields around. And then I'll get rid of this comma. And then I'll rerun this cell to check what the data looks like. Now you can see that the double quotation marks as part of the JSON is gone. This is now a regular SQL string as opposed to a JSON string. And the order of these two fields have swapped around. So now if I do this check, hopefully it's going to pass. Fantastic. Okay, and I think that pretty much wraps up this lab. Let's check out these quizzes. Okay, why do you think we gave our Snowflake stage object a name like a window into an S3 bucket? Because a stage is, you can think of it as like a window into an external data source. Because yeah, a stage sounds like a location. In this case, the location of the S3 bucket. Okay, this question is on case. Which of the statements below are true about Snowflake's case sensitivity? Yeah, so Snowflake always assumes you meant to type uppercase unless you put something in double quotes. So just like we saw with stages, right? We created this object, a stage, and it's always automatically converted into uppercase, or put it another way, Snowflake always interpreted that you meant to use uppercase the whole way through. Okay, and that wraps up that lab. One more to go. All right, the final lab, we've made it, guys, lab number 9. So in some ways, this is the most advanced lab in this tutorial. It's going to bring a whole bunch of stuff together as well. We're going to look at how Snowflake works with unstructured data, such as PDFs, and we're going to use Snowflake's Cortex AI, the Snowflake Stack's AI capabilities, LLM capabilities to parse, classify, summarize, and analyze text. So let's dive on in. All right, let's kick off our usual opening cell, presenting some context information and setting up our notebook session. Unstructured data is Snowflake, right? So unstructured data, when you think of unstructured data, it's usually PDFs, web pages, social media posts, audio, videos, images, and so forth. How do we deal with this sort of data? Well, good thing is, in this tutorial, there's an interesting scenario and use case that we can walk through that actually integrates with some of the plants and veggies data and tables that we set up in the previous labs. It really brings everything together. Okay, so pretend, because supposedly I am someone who's obsessed about veggies and plants. Suppose I do a lot of regular research on these things, plants, vegetables, and I go around and I study plants and vegetables out on the field, and I make notes about them. I might write them down and then I might scan them into a PDF. So what do I have? A pile of digital notes, scanned PDFs on my local hard drive that contain insights about various plants and vegetables. That's the scenario. And what I want to do is ideally bring that data into Snowflake. So I want to scrape the text information of all of these insights on these various PDFs into Snowflake. And then we're going to run some LLMs analytics on all of this text to surface some insights about all of these plants and vegetables that I've been researching. Okay, so that's the use case. And we're also going to join some of this. We're going to enrich the data from my PDFs with some of the information on plants and vegetables from previous labs as well. So that's the scenario. What does the data look like? So I've got 130 files, PDFs. Let me execute this cell, which is going to list all of these files. Right, so these are all PDFs with text in them, insights on various plants and vegetables. I've got date stamps as well, checksums, the sizes of these PDFs. So we use the list command in the last lab to basically list files in an S3 bucket. Do you remember we also checked this option when setting up the stage into Amazon S3, this directory table option, right? So now we're going to be able to leverage that. If I run this query, you'll notice that, okay, again, it's listing, right, the files from the Amazon S3 bucket where the PDFs are, but this time round, instead of just presenting a list, what's being returned is something that I can actually query, right? I can do a select star on this list because a directory table turns information about all of these files into essentially an external table that I can then query. Right, and this is going to have certain benefits because I can query this data. I can query this list. So that's directory tables. Okay, now let's check out some of these PDFs, roughly 130 PDFs that I have. I'm going to run this code that generates a link to one of these PDF snippets. It's now saved into my hard drive. Let's open it up. Okay, so we have a fact snippet about asparagus. Interesting. So asparagus is a fascinating plant with several interesting facts. Fantastic. I really don't know much about asparagus. For example, it is a perennial plant, meaning it can live for more than 2 years. It's also a member of the lily family. One unique characteristic of asparagus is that it is dioichi. I'm not going to attempt to pronounce this late at night, which means there are separate male and female plants. That's interesting. Additionally, asparagus has a high level of inulin. I thought for a second I was going to say insulin. A prebiotic that promotes gut health. Cool. And it's rich in vitamins and minerals such as vitamin K, vitamin C, and folate. Okay, very interesting. Wow, that's actually puts me in the mood to read up on some of the other roughly 130 PDFs and learn more about these vegetables. But thankfully I don't have to, because by the end of this lab, we're going to be feeding all of these PDFs into an LLM that can present this information in a much more streamlined way. Asparagus, who knew? Indeed. Okay, to set up the tools and architecture to do all of this analytics, we need to talk a little bit about Snowflake Cortex AI. So Cortex AI is essentially Snowflake's managed AI service, and it lets you use powerful LLMs directly inside Snowflake through either Python or SQL. That's how you interface with these LLMs, and you don't have to build or host any of the AI infrastructure yourself. It's AI on demand. And essentially, it allows Snowflake to bring AI to your data instead of forcing you to move your data out of your data platform to where the AI tools are. Very interesting. And this is generally where the industry is heading. For a number of years now, vendors have been bringing analytics tools, machine learning, and so forth to the data, not the other way around. And now being able to bring LLM and agentic AI capability to where your data sits is just the natural evolution of where enterprise data capabilities are going. Okay, so when it comes to Cortex LLM functions, Snowflake says that you can classify LLM functions into some different categories. There are some task-specific functions that do specific things. You've got helper functions, and then you've got this complete function, which we'll check out at the end of this lab. And we're going to use this complete function once we've brought all of this, the plants and veggies inside data into Snowflake. We've cleaned things up a bit, and we can then use the complete function to perform LLM-based analytics on this clean data set. All right, but before we get there, let's check out some necessary task-specific functions that we'll need to get to where we need to go. So first up is this parse document function, which is used to extract text using OCR from a PDF. Right, so let's take an example. So the snippet PDF on asparagus, we can run the parse document function on that PDF, and it's just going to extract the text that was in the PDF. Right. For mode, we can use OCR. OCR has been around for decades. These days it uses neural networks to read the data, read the text. But very interesting, before neural networks came along, OCRs use basic pattern recognition to try and work out what the letters were. Like, for example, if it had a line and then a curve, then it might have guessed that the letter could have been, for instance, P. Anyway, OCR is used to read text. The other option here, I believe, that's available is layout, which not only reads text, but tries to understand the structure around the text as well. Okay, so that's parse document. And with parse document, we actually have enough scaffolding to build a text extraction workflow. What we want to do is we want to create a table called vegetable knowledge base that brings together all of the insights from these 130 PDFs. And we also want to associate them with the plant or the vegetable that the insight is on. And this basically forms kind of like what you might call an analytic base table in data science. It's the clean data set that you're going to run analytics on, run modeling and analytics on. So first up, let's create this empty vegetable knowledge base table. It's going to have 3 fields: the name of the PDF, the insight that's in the PDF, and then what the associated plant or vegetable is going to be for that insight. Okay, successfully created. So let's validate that. We'll go to our database explorer. We'll go into our garden plants database, go into veggies, go into tables, and here we are, vegetable knowledge base. Okay, and there's no data in there yet. Next up, we want to use the parse document function to pull all of the insights from the 130 PDFs to populate this blank table. So let's run this code. There we are, we've inserted 129 rows into the table. Let me refresh the page to see what that looks like. And here we are. Okay, cool. All the insights, thanks to the parse document function, scraping the text from each PDF, we've now populated a table and brought together all of these insights into one table. Okay, let's programmatically check that as well. Select star vegetable knowledge base. Okay, there we go. Here's the table. Now, we do have a problem noted in the next cell. We've got the document names, we've got the insights in the document, but we don't know which plant is associated with that insight, right? So for example, this insight, lima beans, blah, 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 blah. Clearly this is talking about lima beans. We want lima beans to be here, but it's not here, right? How do we get the relevant plant to appear in here? So this is where Snowflake has a function called classify text. Essentially what you do is you present a phrase and you present a list of categories, and then the LLM is going to classify your input into one of the supplied categories. So for example, if we supply some animals, dogs, cats, sheep, goats, rabbits, these are predefined categories, and then we supply a string, for example, border collie, the classify text function can then classify border collie as, well, is it a dog? Is it a cat? Is it a sheep, goat, or rabbit? It's going to use an LLM to find that context and do that classification. So how is that going to help us here? So this is where I've got to give credit to Snowflake for designing these tutorials really well. We have a bunch of categories of these plants and vegetables from the previous lab. If we go to vegetable details, we have a list, a full list of the vegetables and plants that can serve as our categories. So what we're going to do is we want to pass all of these plant names as categories, and then we'll use the classify text function to classify each of these insights into one of these plant names, which is pretty cool. We're using Cortex AI functions and bringing together the hard work that we did in the previous labs. Okay, fantastic. This is just a piece of code, SQL script, to just illustrate what classified text does. So our input string is apple. Is that one of these? Which category does apple belong? Is it a fruit? Is it a veggie? Is it a flower? The LLM has classified it as a fruit. Just out of curiosity, what does it think a tomato is? Is it a fruit or vegetable? Because this is the one that is scientifically meant to be kind of both, right? Cortex AI turns up with fruit. Okay. If you guys want to let me know in the comments, is a tomato meant to be a fruit? Or should I say, is a tomato considered closer to being a fruit or a vegetable these days? I don't know. You let me know. Okay, so let's now run this SQL script, which is going to do that classification, right? It's going to run through each of our insights and then attach to each insight which corresponding plant the insight is on. Okay, number of rows updated. Let's now query our hopefully completed vegetable knowledge base. All right, sweet, looks great. Lima beans. So the plant is actually, it wasn't lima beans. That wasn't an option in our vegetable details table. Instead, beans and lima was the closest plant. Okay, cool, cool. Artichokes are not only delicious, blah, blah, blah. The associated plant is artichoke. Fantastic. Pumpkins thrive in well-drained, blah, 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 blah. Associated plant is pumpkin. Okay, nice. Let's run a quick analytical query to go through the list of plants and check out how many knowledge articles, right? In other words, how many PDFs, how many insights were on each of those plants. And this will give us an idea of, in our journey, throughout my journey of collecting all of these insights, I may have collated more insights on certain vegetables than others. Okay, let me sort this. Can I sort? Order by, so currently it's ordered by plant name. So it's alphabetical. Let me order by the number of articles. Oh, I actually want them descending. So then I know which plants attracted the most amount of insights. Okay, carrots, pumpkins, zucchini, beans, squash. Okay, cool, cool, cool. And then which plants didn't have any insights collected? Sweet potato, edamame, endive. Don't actually know what that is. Okay, cool, cool. Next up, Streamlit. So Streamlit, it's a Python library that helps you build web apps. And here we're going to use Streamlit to actually create a nice little visualization to show the distribution of insights per plant. So we can see edamame, endive, sweet potato don't have any insights, no knowledge articles on those. And we can quickly see which plants did top out with the most number of knowledge articles. Cool. Okay, so Snowflake really wanted to show off these two additional task-specific functions. They're not going to play a role in this kind of plant veggies narrative, this storyline we're going through. This is a bit of an interlude topic. Okay, so how do we use translate? Basically, you give a text in one language and it's going to translate it into another language. So let's run this cell to demonstrate an example. Okay, so here we've grabbed the original knowledge base table and we've injected two extra fields in. One of them is a Spanish translation of the English text. And then just for, I guess, checking purposes, it's then grabbed the Spanish text and there's a new field that then converts back to English. And then if you're keen, you can compare the original English text with the English text that was translated back from the Spanish, just to see how much, I guess, Chinese whispers there were translating this text. Okay, cool. Next up is the summarize function. So this can be used to basically grab a bunch of text and just provide a summary of it, hopefully in a more concise way. So let's run this code and see how it works. So what's happening here is we've picked a particular plant, pumpkin, and this had a number of insights on it, a number of knowledge articles. So if we go back up, how many did pumpkin have? Whoops. Okay, if I scroll up and down my mouse, I can actually kind of zoom in and out of this visualization. That's pretty cool. Anyway, if we go back up, pumpkin, so here I will actually, oh, there it is, pumpkin. 6 knowledge articles, right? So pumpkin was one of our list toppers, right? Had the most number of knowledge articles. So what this code did was it basically grabbed all 6 pumpkin knowledge articles, and this function, list ag, essentially just concatenates all of these input strings together. That added up to around 1,300 tokens. And then the AI ran this summarize function on this aggregate, kind of all the insights on pumpkin pulled together, and summarized that information, condensed it, was able to provide a more condensed summary. Like, let's compare the original. Now, unfortunately, I can't expand this, but yeah, these are all the insights. It's kind of long. AI was able to summarize that into something much shorter with far less tokens. So that's the summarize function. In a nutshell, it's kind of just like pasting a big block of text in ChatGPT and asking for it to give you a brief summary of the text. Finally, kind of the big daddy of functions available in Snowflake Cortex AI is this complete function. And you don't have to think too hard about this. It's basically just a prompt window. You give an LLM information and instructions, and the complete function is going to process that and return an output. That's all it is. So let's go through an example. Oh, okay. Failed to fetch pandas data frame. The model Snowflake Arctic has been deprecated. Okay, so this model, Snowflake Arctic, this managed model from Snowflake is no longer available. Let's try Claude. Claude 4 Sonnet might be available. So let's try that out. Okay, there you go. Yeah, so complete. Really, it's just a conversation with an LLM, right? We're going to use this specific model. I'm going to give this prompt. You are an IT expert. Explain to me what Snowflake is, and the complete function just generates an LLM-based response. Snowflake is a cloud-based data warehouse platform, blah, 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 blah. Okay, so the final task in this video, this tutorial, is we're going to bring together everything, and we're going to use the complete function to perform some analytics on the knowledge base table that we've constructed. Here it is, the vegetable knowledge base table. We got a whole bunch of insights and associated plants, and we can now query, perform analytics, use LLMs as a prompt layer on top of this table. So let's check out what that looks like. So here is the prompt. Kind of looks a bit complicated, but all it's saying is we have to declare a question we're interested in. So for example, which plant will take the shortest amount of time to cook? Now, 5 years ago, if you had the vegetable knowledge base table, you'd have to kind of go in and read all of that information, all of the insights, 130 rows, row by row, and try to extract that information somehow. But we're going to use the complete function. We're going to use an LLM to get that information for us. So this is the question. The prompt is, you are a helpful gardening expert. Use only the supplied information. This tag is actually not necessary. It's meant to help the LLM identify important parts of the prompt, but you can delete these if we wanted to. I think this might actually be a typo because this tag opens, but it doesn't close later on. Don't worry so much about the tags. All the prompt is saying is use only the supplied information to answer the question posed. And what is the question posed? It refers to the save variable from above that was set here, which is this prompt, right? This question here. Which plant would take the shortest amount of time to cook? And then it says, look, if you have no supplied information, don't answer. In other words, don't hallucinate. If you don't know, you don't know. And then at the end, it's feeding all of that, the prompt plus the question, into an LLM via the complete function. And what's the LLM that we're choosing? In this case, it happens to be mixed rule, but you can swap this out for other models. Which plant would take the shortest amount of time to cook? Well, based on the information provided, so it seems like the LLM is saying there was information provided, lima beans would take the shortest amount of time to cook. They can be cooked in various ways, such as boiling, steaming, blah, blah, taking around 20 to 30 minutes to cook until they are tender. Okay, interesting, fantastic. And that pretty much concludes the Snowflake training session. We've gone through 9 notebooks, covering everything from how the user interface works, how to access data, how to load data and wrangle it in the Snowsight UI, all the way to understanding compute, how to check your code, how to monitor your queries, do some data engineering, play with semi-structured and unstructured data, using AI to process and gain insights in your data inside Snowflake. We've covered a lot, but yeah, let's quickly go through the final quiz. If we run a select statement that has worked in the past, and now you get an error saying the table doesn't exist, what should you check? You've seen in this tutorial that it's going to be a context problem, typically. Which of these objects has the most compute power? Which of these concepts is actually related to compute? It's not database, it's not schema, it's not sequence, not data mart. It's warehouse, because in Snowflake, a warehouse refers to Snowflake compute. Which of these objects is the lowest in the storage container hierarchy? Table, because the hierarchy goes like this. Region, so the region it's like a data center. It's geographically somewhere in the world. You've got then account, right? So the account that I've logged into is this account. And then I've got database within that account. I've got schema within that database. And then I've got a table within that schema, right? So table is the lowest in the container hierarchy. Okay, which of these statements below describe an external stage in Snowflake? So external stage is like an external data source. It connects Snowflake to an underlying external storage location. A stage can provide a window between Snowflake and a cloud folder, right? Snowflake really likes you thinking of a stage as like a window between Snowflake and a cloud location. Which of the following is not a Snowflake Cortex LLM function? Translate is, we played with that. Summarize is, we played with that. Pass document is, we played with that. Count tokens, we have not played with that. Oh, wrong, okay. Content, we have not played with that. Okay, so it turns out this is the one. And complete, we did play with that. It's basically a way to interact with an LLM with a general query, but the right answer is content. Congratulations, you have completed the course, well done. Look, I have no idea how long this video is gonna be, but I spent a bloody long time recording this. So if you've made it all the way through to the end, congratulations to you. Let me know in the comments if you watched the whole thing. I'd be very interested to know if anyone had the perseverance to go through all of these 9 notebooks with me. Hopefully you found this long tutorial valuable and you now have a much better understanding of what Snowflake is about and its capabilities. All right, let's leave it there, everyone. I'll see you in the next video. Cheers.